In this video, I am going to solve this second order constant coefficient homogeneous differential equation, and it is y double prime minus 9y is equal to 0 with initial conditions y of 0 is 3 and y prime of 0 is equal to negative 6. So this falls in the general structure of this type of equation, which is a y double prime plus b y prime plus cy is equal to 0, where a, b, and c are constants, real constants. So our assumption here is that the solution to this type of equation, second order constant coefficient homogeneous differential equations, will be of the form y of t is equal to e to the power r times t, where r is a constant. Now, if that is the assumption that we make, we have y prime is equal to r e to the power rt and y double prime is equal to r square e to the power rt. And if we plug in these three values into this equation, I get y double prime, which is r square times e to the power rt, and there is no y prime, so we don't have to put that one in. 9 times y e to the power rt, all of it equal to 0. If we factor out e to the power rt, we have r square minus 9 is equal to 0. Obviously, this is an exponential function, hence is not equal to 0. So this must be equal to 0, right? So r square minus 9 is equal to 0, or r square minus 3 square is equal to 0, which is a square minus b square, which is a plus b times a minus b, or r plus 3 times r minus 3 is equal to 0. So my conclusions are that either r is equal to 3 or r is equal to negative 3. So the family of solutions for this equation is going to be y is equal to c1 y1 plus c2 y2, and y1 is going to be, by the way, e to the power, so let's put it here, y1 is equal to e to the power 3t, and let's say y2 is equal to e to the power negative 3t. And one thing I should mention here, this equation is called the characteristic equation. So the characteristic equation we can solve and then find the value of r here, which we did here in our case, 3 and negative 3. Now let's go ahead and write it out. So it's going to be c1 e to the power 3t plus c2 e to the power negative 3t, right? Now y prime, we need to find that. Y prime is going to be 3 c1 e to the power 3t minus 3 c2 e to the power negative 3t. And this one is going to give me, remember, t is equal to 0. So e to the power 3t and e to the power negative 3t are going to be just 1, because e to the power 0 is 1. So this one is going to give me c1 plus c2 is equal to 3. And this one is going to give me 3c1 minus 3c2 is equal to negative 6, because y prime of 0. And this I could simplify further. c1 minus c2 is equal to negative 2 by dividing both sides of this equation by 3. And this one tells me c1 plus c2 is equal to 3. If I add these two equations, I'm adding, that's going to give me 2c1 is equal to 1, or c1 is equal to 1/2. So c1 is 1/2, so c1 plus c2 is 3. c1 plus c2 is 3. So C2 is gonna be 5/2 or 2.5. So my final solution is gonna be y of t is equal to 1/2 e to the power 3t, okay, plus 5/2 e to the power negative 3t. And this is going to be solution to this differential equation with this and this initial conditions. I hope that this discussion was helpful. Thank you very much.